That's the Unit 3 content. So what I'm thinking about, Miss Cluster, would you be okay with answering questions on sequences and series? Or would that be, have you looked at that at all? Because we could do, like...
We can do the, you know, what we covered last week.
Mm-hmm.
I think didn't we cover the sequences?
Mm-hmm. We did.
Geographic sequences.
Well, and if you're not okay, if that's not good, then they can just watch that recording. So, and here's what we did in the last session, guys, is Miss Cluster had her room open, and I've got the link still there, and she was just answering some questions from students that were in a previous unit. So if you have something specific that you need help with, that you want cleared up, I don't mind if y'all want to go to Miss Cluster's room and work on that. I kind of want for this lesson to be about what I planned on, because I want there to be a recording for when you get there, that there's something that you can refer to. So if you have something you need help with, and Miss Cluster, you can link me, or you can use that teacher pod or whatever, if there's something that you're not sure about or where it is or whatever. Is that too disjuncted, or is that okay?
That's fine. I need to open my room for...
Okay. All right. So if you have a question about Unit 2, or, you know, and it may just be that you just need to finish it, which, you know, that happens. So I'm going to go ahead and talk about conic sections, take notes on it, and know that this is the information that's coming. And when you get there, this will help you. Okay? I've got a video clip, and I want to give it to you at the end, because you can watch it after I move on to my next group. So I just wanted to mention that. And it's kind of cool because it shows you a three-dimensional cutaway of what a ellipses, hyperbolas, and parabolas. And at the video clip, they actually do a digital, and they turn it so you can actually see what it is, and I can't, there's no way I could draw it. So I'm going to show you all that video clip. Don't let me forget. So that's the key, is don't let me forget to share that link with you. When you look at this first lesson, all they're trying to get you to do is understand the I like to know generally what I'm looking at as far as which conic section is which. So when you're looking at the equation in this format, it's just like 2x squared plus 17x minus 14x plus 22y minus 17 equals 0. If it looks like that, if the if those coefficients are not the same, but they're the same sign, so they're both positive or they're both negative, then it's an ellipse. Okay? If A is not the same sign as B, so if A is positive and B is negative, or the other way around, it's always a hyperbola. It doesn't matter if they're the same number. If the signs are opposite, then it's a hyperbola. And you don't even know what a hyperbola is. This way. If, let's see if I can write it on here. If A equals 0 or B equals 0, then it's a parabola. There you go. Okay, so if either of those. if A equals 0 or B equals 0, then it's a parabola. Okay, so all you're doing, it doesn't matter. All the rest of the equation doesn't matter. The only thing you're paying attention to are the two terms that have the squared variables. Okay, I'm going to give you all a minute to write that down, because I don't think that's given in the book. That's just Mrs. Long's take on okay, Miss Cluster has her room open, so if you have a question about Unit 2, you can pop over there, because the link is right above the chat pod. All right, so give me a green check when you've got that written down so I can know to go to the next thing. I don't think it's given to you in this format. You're working through these lessons. If you come up and you're like, I'm so frustrated, go back to the live lesson recording, because I'm going to give you a very straightforward way to look at these conic sections. All right, Cody, let me know when you get that done, when you write that down, and Brianna, you as well. As soon as y'all give me a green check, we'll move to the next thing. So that bottom part says if a equals 0 or b equals 0. In other words, if there's only an x squared or there's only a y squared. All right, excellent. So Cody's got it. So when you're doing that first lesson, great, Brandon's got it. When you're doing that first lesson, if it says what kind of conic section is this, all you're doing is comparing those coefficients. All right, now I want to talk about is the focus and the directrix. And now we're going to have sideways parabolas. That's not the math term, that's Miss Long's term. They call them horizontal parabolas. I call them sideways parabolas because they open to the side. All the parabolas you've ever dealt with in your life opened up or down. Now you're learning that there also can be sideways parabolas. Good. And you might have done some of these before, absolutely. And here are the general formulas. Now here's the thing that you have to understand that I think that is not made as big a point as it should be. The thing to understand and know is the distance from the focus to the vertex and the distance from the, I'm going to put it out here, is the same, and it's c. Okay? And it doesn't matter if it goes this way. The distance from the vertex to the focus and also the distance from the directrix to the vertex is c. And that's important because c is in the formula. Now, what do you notice about these two formulas? They kind of look similar. You should feel familiar to the differences. It's, yeah, can the x and the y are switched. Yeah, there you go. Here's the thing that as a student always tripped me up. Always. Let me get a different color here. You know the vertex is HK. That's familiar to you. You've done that before, right? The H is the X part, right? The K is the Y part. And the formula that you're used to is the X minus H squared plus K. But look here. The sideways one has Y minus K. The Y part of the vertex stays with the Y variable. It's Y minus K, then the H is on the outside. All right, do y'all see that? The Y minus K squared is the sideways formula. And the K is the Y part of the vertex, going with the Y variable. So if you have an up and down, right, sideways, like crickety, right. And if it's a sideways parabola or horizontal parabola, it's going to be Y minus K. The Y part of the vertex stays with the Y variable. The X part of the vertex stays with the X variable. Does that make sense? Do you see the difference? And I'm going to let's do some problems with it so you can see what. Now, when you look in the book, you're going to see a bunch of formulas. I'm never ever going to use those formulas. When I need them. On every single problem that I do for conic sections, I'm sketching a picture. Because if I can see the picture, I don't need all those formulas. And the wrong thing, and it's always very frustrating. So if you love formulas, that's great. Use those formulas. I do not love formulas. I will not be using the formulas. But I can show you how to do it. I'm just going to have to look at them. I just can't remember them right off the top of my head. Now, the two that you have to have for parabolas are these two. going to do with that? Here's what we're going to do with that. First of all, we're going to write the problem down. Let me get rid of that. That looks like a mess, doesn't it? Whew. Okay, where did my pencil go? Oh, there it is. All right, let me write the problem down real quick. It's the vertex is for 1. Hold on. I know you can't see it. Just a second. Now you should be able to see it. Does everybody see my little whiteboard? Okay. What I'm going to do every single time I do one of these problems is I am going to sketch a picture. Because I don't know anything about this thing, but once I see the picture, and this is my vertex. Just because I know what I know about parabolas, I know this parabola opens sideways. Because the focus is always on the inside of the parabola. And I didn't have to remember a formula for that. All I had to do was plot what I know and go, oh, I know which way this thing opens. Now that I know it opens sideways, I know which general form I'm going to use. And that's exactly how I write it, so that I don't have any mistakes of putting the Y and the H together. This looks like a 4, doesn't it? It's a Y. Okay. Easily. The HK they already gave us. They gave us the vertex. Right? And remember I told you that the distance from the focus to the vertex is C. Formula. So I'm going to plug in 2 here. I'm going to plug in my H, which is 4. And I'm going to plug in my K, which is 1. And then I'll have what am I graphing? Parabola. Parabola. There we go. Ooh, that really had to search hard for that. So we got 1 over 4 times 2 equals times. Sorry. That's a great question. Let's write the equation of that as well. Let me fix this real quick. Because sometimes they give you the directrix. So there's the equation of our parabola. What would the equation of the directrix be? Let me do that in a different color. Let me pick blue. I know that that's 2. So 1, 2. I know that my would just be 2 units in the other direction. Does that make sense? It's not an ordered pair. It's an equation of a line. A directrix is the line. That's a good question, Daniel. Does that make sense, though? Okay, cool. Because you can come up with the equation relatively easily. All right, anybody else have questions about this one before we do the next one? These are really straightforward, but you have to have those 2 formulas down. And you have to know the directrix to the vertex is C units, and the vertex to the focus is C units. It is simple. Comfortable with it as well. All right, let's do number 28. I did We have a little bit to do here. We can't graph this. This isn't in the graphing format. But we can make it be what we want to. Because, okay, here we go. Y equals x squared minus 8x, oops, plus 17. Now, right off the bat, we should know which way it opens. Is it going to open up and down or left and right? You base it on what is squared. So which way does this one open? She's gonna guess. I'm proud of you. There you go. It is. It's gonna open up because the x is the variable that is squared, and we know that there's a positive number here, so we know that this parabola, when we go to graph it, is going to point upward. If the y was squared, then we would know it was left or right. But since the x is squared, we know it's going to be open up or down. Okay, now we need this to be in the format of 1 over 4c square. Remember how to complete the square? If you don't, we're going to practice it. All right, we're going to kind of leave the 17 out there by itself because we don't really need him bogging up our completing the square process. All right, now we have a 1 here, which is what we would want to complete the square, so we don't have to do any extra work for that, which is nice. And we're going to take our middle term, half it, do you remember how to, do y'all remember completing square from before in your math life, hopefully? Even if you don't love it, by the time you get done with this unit, you will be a great completing of the square person because you have to do it all the time. All the time. All right, so that special, great, and wonderful number. Doing both, we don't change the equation at all. We could have added 22 and took away 22, but that doesn't help us. We added this special number because it makes this part a perfect square trinomial. So then 16, that's a -1 out here. +1, sorry. Yes, I know how to add. Look! We're in graphing format! And I do that because my feet swell up from sitting at my desk all day. All right, so what's our vertex here? Everybody's waiting. I have to let you do it all. Oh, nobody's typing came through. Oh, writing it down. That's right. It's going to be your h is 4, because remember the x minus comes from the formula. So you have a vertex of 4. It opens up because the number in front of this is a +1, right? Now that doesn't look like a +1. I don't know what in the world that looks like. for C. In this case, there's a 1 here. So if there's no number, you assume that there's a 1. Right? There's a 1 here. What is C? So what happens is you've got an ordered pair right here that's the focus that has a distance of 1/4, and you have a directrix right here that has a distance of 1/4. So this one's going to be y equals 3. Right? If you have a dollar, if this was 75 cents, this would be 25 cents. Right? And then this one, the focus ordered pair, would be still of your focus. I didn't have to remember a formula for that. I just could count. Now, if you like formulas, there are some formulas that have those information. But for the majority of the students that I've had in the past, the pictures and understanding the relationship of the pictures seem to work so much better. All right, so our focus is 4 1/4, and our directrix writing it down, and I'll wait just a second and field those questions. Let's do like, put that back up there. Sorry about that. All right, so then when you get done writing that down, give me a green check so I know, and I'll quit. I'll give y'all just a minute to process. I know I went through that very quickly. And it's hard because I can't see your faces to see if I'm doing it too fast or not. All right, y'all are writing. I know I'm being disruptive, but my son did not have school today. And he is still asleep, and it is 1:30 in the well, he spent the night at a friend's last night, so my guess is they didn't sleep at all. Yeah. And if I wasn't in live lesson, I'm just like, okay, what have I written down? Do I need to go back over that? It's all good? Okay, cool. One standard equation of a circle, and there it is. Circles to me are the easiest conic section. The H goes with the X, the K goes with the I, Y. The center out. And don't get that confused with the diameter, right? The diameter goes all the way across and through the center. And thanks for letting me know. Okay. All right, so here it says find the center and graph. So that's what we're going to do. All right, so we got minus 4y minus 16. All right, let me write that down. All right, because Daniel's a great guy. All right, it was x squared plus y squared. Was it minus 16? Minus 4 minus difference for y. All right, let me get this where y'all can see what I'm writing. Okay. We want to find the center. Together. Well, there's only one x term, so yay, that one's easy. Then we're going to put the y's together. And then we're going to put the number that doesn't have any variable by itself. Okay. If this had an x term, we would complete the square. It doesn't. So we know that the h is going to complete the square. We're going to take our middle term. We're going to half it. And we're going to square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. That's so here's the thing to remember. If you add and subtract on the same side, it's the same as adding to both sides. I just got this ready to get the vertex. Okay, so we have this problem all ready to roll. So we have x minus 0 squared plus, oh, this is a y, hello, y minus 2 squared. Because my radius, this is radius squared. That's a really good question. The format for this problem has the radius on this side. Over here, you're going to add and subtract. But since the circle has the radius by itself, you can add to both sides. Does that? And that's a very good thing to get straight. Does that make sense of why I did it one way for one of them? Okay, cool. And that's a very good thing to get straight because sometimes students try to do it one way or the other all the time and it won't work. And it's, you have to keep in your if we had left the 16 over here, then we could have just added 4 and taken away 4 and then moved the 16 over. That would have been the same thing. All right. HK. And our radius is the square root of 20, which is right. I don't know what that looks like. It's a little squiggly equals because I'm rounding. So if we were to sketch that, it's really easy to sketch. 0, 2 would be here. And then I would go up 4.5, I'd go down 4.5, I'd go right 4.5, and I'd go left 4.5, and then I would sketch my little circle in. This one would be the negative square root of 22. Right? This one would be 2 plus the square root of 20, 0. And this one would be 2 minus whiteboard with a mouse, little, minus the square root 20, 0. All right, that's a lot to keep track of. Dog, get off the table. Sorry, I tried to put it there. So I didn't feel like fighting with her today. And now she's on the table. Okay. Questions, questions. Everybody good? Or y'all just writing it down? I'll wait just a second. Just type in the chat pod when you're done. That either you have a question or that there's no focus point. There's no other anything else. There's no asymptotes, which you'll see when we do hyperbolas. There's just that, not that much to get confused about. All right, Delaney's good. Oh wait, that was from before. All right, super. All right, we'll wait for Cody and Brianna. Awesome. Awesome. Okay, so let's do the next thing. I think, where was that the last thing? Let me see. Okay, that was all. Oh my goodness. Well, this week we're going to talk about ellipses. All right, so practice those parabolas and circles, and the next week we'll talk about ellipses. And so we'll do them little by little by little, but the goal is for you to practice, practice, practice. Let me see if I can get that video up. Hold on just a second. And that as well, because I know some of y'all are finishing up. Here is the teacher tube. If you'll click on that and then hit browse to, you'll hear the sound. And I really would like you to take a few minutes and watch that. And we'll do that now while the recording's rolling. And then if you have questions about it, you can let then give me a green check.